right, so we're on, this comes from section 5.7 of your book. We're going to write the polynomial function, call it whatever letter you want, f, g, t, we'll just say f, given the zeros. We're working in the reverse direction now. So, for example, and I have to say before I start, there's a lot of assumptions I'm making to simplify this. I'm assuming that the zeros are all real and rational, okay? And they don't have to be, as you know from factoring and solving, right? What other types of solutions can you get besides real solutions? Are there any other solutions possible, or are they always real? They're not always real. What else are they? Imaginary, exactly. And do they have to be like integers or fractions? They can also be square root. And what's the mathematical word for square root of a number, like root 7? What type of number is that? It's not rational, it's irrational. So you have all this process of working backwards can be quite complicated. And you have imaginary solutions or irrational solutions, but we're just assuming, we're going to keep it as simple as possible. So we're assuming only rational. Assume rational zeros, and the leading coefficient is 1. Because if it's not, then we still would need more information to find the equation, assuming leading coefficient is 1. So to just go to the heart of the matter and just what you need, I'm keeping it simple. So for example, if I tell you the zeros are, or you look at the graph and you see that the zeros are -1, 2, and 4, and then I say, okay, tell me what the polynomial equation is of the lowest degree possible. What's the lowest degree that the polynomial could have? Could it be x squared with 3 different solutions? No, yeah, x cubed is the lowest, okay? So we're assuming it's going to be x cubed. These are all just regular roots. What is the equation? So we have to work backwards. So what you do is, the answer is this. And then you can go straight to the answer, but we have to write it in a nice form. So the answer is like this. If these are the roots, then one of the factors is x plus 1, right? Because of the zero product property. And another factor is x minus 2, because of the zero product property. And the last factor is x minus 4 because of the zero product property. So basically all your factors will look like that because we're just keeping it simple. And then we're going to just write it in the form that we want to see it in, so we're just going to distribute it all back out. So equals, alright, so this is just good practice of multiplying polynomials using the distributive property, right? You just FOIL this out, distribute the x, distribute the 1, x times x is x squared, x times -2, -2x, 1 times x, and 1 times -2. So distributing, you get that when you multiply the first two together, times x minus 4. Okay, and then we're going to combine like terms to make it look nicer. So you get x squared minus x minus 2 and times x minus 4, and we still have to finish multiplying this out, and we'll get a third degree polynomial that we're going to say is our answer. So we're going to distribute, what you do is you distribute the x squared to both, then you distribute the negative x to both, and then you distribute the -2 to both. So x squared times x is x cubed. This is good practice with laws of exponents. X squared times -4 is -4x squared. So that's done. We finished distributing the x squared. Now we're going to distribute the negative x. Negative x times x is -x squared. Negative x times -4 is plus 4x. And then negative, so we're done distributing negative x. We distribute negative 2 times x, negative 2x, negative 2 times negative 4 plus 8. And all we're left to do for our final answer is combine like terms, and then I'm going to let you try an example. So f of x equals, we have 1x cubed, so we leave that alone. We have negative 4x squared and negative 1x squared is negative 5x squared. We have 4x minus 2x is plus 2x. And we have our lonely little 8, which can't be combined with anything else. So this is our answer. And so I want to pause this video. I wonder if I can do that. I'll have to play with that later. So I'm going to stop it.